Hey, Mr. McLaren here. So I want to go over how to do CERs today. I'm gonna be talking specifically around the um, the beach erosion CER. But before I did that, I want to give you this video to just give you some context about what claim evidence reasoning is. So CER, that's what it stands for. Um, so to just first of all about this assignment, these things are pretty difficult to do. Like, honestly, my eighth graders who graduated last year, even they were still having a hard time with some of the evidence and the reasoning. And that's okay for us to be struggling on this stuff. So this score on this assignment, I want you to know, is not going to negatively affect your grade. This won't hurt your grade. So the score, if you're trying this assignment, is going to be full credit, but you're going to need to resubmit this. I'm telling you right now that I'm going to give feedback and you will have to resubmit this. No one's going to get this perfect the first time, I can guarantee you. You'll see why. It's pretty tricky. But we're trying to get better at this, and this is a really important skill because without understanding CER, I believe that we can't really interact with science in an honest way. So it's a super important thing that we are going to be covering over next week, essentially. Like we'll be getting some practice with this CER and revising it next week. I need to figure out exactly how that's going to work day to day. I'm still building as we go, right? Okay, so let's actually go into what we're doing today. Basically, that you should be doing this on Friday, watching this video and responding, and then submitting this. The feedback piece, that's going to be more of what we're working on next week. So don't worry about resubmitting over the weekend or anything. We'll do that more like next week. Um, I don't know how many comments I'll have to people by the end of Friday, but we'll see. I'll try. So basically, this is what you're gonna see in general when you're doing a claim evidence reasoning. Is you're going to see a page that has some claim on it. You're going to have a page that has some area where you're going to have some evidence that I'm going to try and provide to you. Like, this is the evidence that you're using, and you need to tell me what observations you're seeing or what data. Actually, I should probably put data in there. I'm gonna just do that. And then you're going to explain why that evidence supports your claim, essentially by using some scientific ideas. Now, if I just said that, this is basically what the district has provided for students. And if you want to try and pause the video and just answer the question, it's actually going to be a slightly different question. I need to switch this out. Just give me a second. Okay, so this should be the question that you're going to be responding to. You should see that on your slides. I think it should be slide 4 for you. I might tweak things a little bit. Like I said, I'm building as I'm going. You'll see why the previous claims didn't really work. I'll try and explain it a little bit in the video, but it's going to get a little deep. So just a fair warning. So yeah, basically, if you wanted to take a swing at answering those now, you can do that, and then you might want to work on it a little bit after I've talked a little bit more about the CER. So just a brief overview. A claim is just a short answer to a question. Evidence, this is really just like data or observations. This is something that you can measure, and that someone else can also measure and get the same results. And then reasoning is some sort of explanation that includes some sort of concept or terms that you're using appropriately to explain the claim. Here's a really important piece though with evidence. A lot of people, they confuse evidence and reasoning. They kind of like put those things together and they think they're the same thing. And in language arts classes, they oftentimes tell you they are the same thing. So for example, a language arts teacher or a history teacher might tell you someone's account or firsthand account of something is evidence. In science, that is not the case. You have to make a measurement so that I can also go to my lab and make the same measurement and confirm your results. Or I can go to the same place and I can see the same things. That is what evidence is for scientists. And it can get a little bit confusing because like other people they'll give you some logic They'll see like, well, this makes sense, or like, I don't think that person could have been there given these other like eyewitness accounts. Like that's reasoning. That to me is not evidence. So it's important that we're separating the two, especially when we're talking about science. To clarify, like the evidence has to be something that another scientist can confirm or see for themselves. Sorry, random quick tangent about the Romans. Just an example about them using logic as evidence. For example, people used to think about like atoms and like the Earth being flat or round, and they would just like talk about things, and they would come to conclusions from their conversations about like what made sense, you know? And uh, when they transitioned to doing actual measurements and confirmable measurements, they were able to see that the Earth was indeed round. But that was only by having experiments that other people could reproduce in other places around the world, being able to measure things about like the sun and how the shadow comes down in a well and all kinds of crazy stuff. They were only able to get that and move forward with that when they actually got measurements. And before that, it was just a battle of ideas, and nobody could win. You know, it was just who sounded better would win, and that's not science. We want to know if the Earth is round or not, and it doesn't matter who is more charismatic. Ideally, we'll get to the bottom of if it is round or not, which it is, because we can measure things. Like 2000 plus years ago, we were able to measure things and figure this out. So yeah. Okay, so this is the general rubric. This may change. This is not for the specific assignment. I wanted to use this to go over like just the general idea of a CER and what makes these things good at the different levels. And then we're going to go over a silly example and an unrelated science example. And then you're going to attempt doing the CER yourself for the beach erosion. Then next week we'll work on the beach erosion more. Okay? So I'm just giving you the silly example, scientific example. When I'm done with that, you go back and work on your beach erosion CER. So yeah, I know this seems like kind of like a whole lot going on right now, but a claim basically is good if it does not include reasoning or evidence. That's the most common mistake I see people doing is they start to go into the other pieces. A claim is just a short, brief answer to the question. It should answer the question completely, and it shouldn't contradict itself. I've seen students who to a prompt, they'll say both yes and no, and then in their claim, and it's very confusing. Like they'll be inconsistent. They're like, it's this case, and then they'll be like, it's actually not. So make sure you're being consistent in your claim, and it's actually answering the question. I've had other people write a claim that's similar to the question, but it's not quite the question. So if you're not sure, that's just a double check about that. Claim's pretty easy though. Most people have that in the strong category pretty quick. Evidence, I've been having a hard time figuring out how to get students to get all of the components of evidence, and I've figured out color coding is the best way to do this. Not just me, I've been working with some other teachers. Okay, so after the video, I just realized that A, it's a half an hour video, and B, I did not go over explicitly how to do these color changes in your text. So this is orange right here. So if you go up to the text color, for if you have selected any of these, it kind of changes that color, and you can highlight some text. So I'm clicking and dragging over that. You can also click there, hold down shift, and then right arrow or left arrow to highlight some stuff. So you've highlighted the text that you want to highlight. You go up to the top here, you go to text color, and the colors that I'm using are this orange for the numbers, this purple right here for observations or units depending on the question, this cornflower blue okay, is for the source, and just regular blue is how the data was collected. So those are the colors that we're using. That's how you change it. So if you want to do like the orange color like that, you would change the text like that. For the highlighting piece, if you're trying to highlight something, it's very similar. If you click and drag over something that you want to highlight, then you go up here, you go to the top, and there's the highlight. It's right next to the text color. This will change the background, or it'll highlight whatever text you're looking at. Kind of hard to see just that, but if I do this, click on that, click on here, that's highlighted. Now, if you highlight anything that you don't want highlighted, you can always undo that with Control Z. Remember, Control Y also redoes anything. Control Z goes backwards, Control Y goes forwards. So yeah, that's how you do the highlighting and the colors. But basically, to have good evidence, you're going to need, if you did some sort of measurement, you're going to need some numbers. And then you're going to need some units if you did some measurements. If you did not do any units or get any measurements, you need to get some sort of observation, so something that you can see or smell or hear or taste. Like, you need something in there that's measurable, either with your senses or with a device. You also need to talk about where this information is coming from, so like what is the source, and how the data was collected. So if they're talking about collecting data with some rulers or something, you need to talk about what rulers they were using. Was it inches? Was it centimeters? How are they measuring what they were measuring, basically? If you aren't getting all of those components, if you're getting part of those components, then you're probably in the good category. So the strong category, the color coding lets you make sure you get all 4 of those parts. And if you're missing some of those parts, you're gonna probably be in the good category. Also, if you have like one really good piece of evidence, that isn't going to make a strong argument. So depending on the prompt, you're going to have different numbers of evidence that I'm telling you that you need. I know this is kind of confusing with the ABC. Don't really worry about that for now. Basically, it's just saying you need 3 different pieces of evidence or 4 different pieces of evidence. Okay? Another thing that I've seen, really common mistake, is students will start using their logic to explain what's going on in their evidence. And remember, we can't do that. This is not a different subject area where they do that. Because this is science, we have to be very clear about what is measurable so that other scientists can target that and double check those measurements. And then we can talk about ideas. But we need to make sure it's easy for other people to look at our evidence and confirm if we got the same measurements. Then if we scroll down, I couldn't figure out how to get this all on the same slide with the font, so you have to scroll down a little bit to see the reasoning piece. Reasoning, basically, there's got to be some concepts that you're highlighting in yellow, and you need to make sure you're using a certain number of those concepts, and you're using them in ways that make sense. So I'll show you what I mean by that. And with this kind of silly example, it doesn't really make sense for the reasoning, but the evidence works pretty well. So if you've never read this story about who stole the cookie from the cookie jar, it's a like classic kids story in America, where basically, if you're not familiar, in America, there's these things called cookie jars. They're oftentimes in kitchens, and when people bake cookies, they often put them in the cookie jar, and it like seals it, so it makes the cookies last a little bit longer if it's a good cookie jar. So you got this jar, you got some cookies in it, and a common thing that happens is that sometimes the cookies just disappear. So let's say last night that my brother had the last cookie, or I think he had the last cookie. Now I have to determine this as a scientist and go through this process scientifically to really figure out if he did this or not. So our prompt is, who stole the cookie from the cookie jar? My brother stole the cookie from the cookie jar. Now, I think that originally this had said respond here. And then I had typed this in. I'm not going to type it in again right now. That's kind of a waste of my time. But what I did want to show you is, because we're using the color coding, I think we should change this back to black. Like the general font should be in black, but you should be typing your answers in the box. So here, our claim, if I'm looking back at our rubric, but if we look at the claim is brief, it does not go into reasoning or evidence, it's consistent, it's not like contradicting itself or anything. So this is definitely strong right here. Like this is a strong claim. You don't need more than one sentence usually, though I do want them to be complete sentences. So for this, this is what it might actually look like. Sorry, this should be black really. That should also be black for you guys. This is what a final response would look like with the color coding. So you can see this evidence that I've provided. This first evidence source was, let's say I know that my dog likes to eat cookies, but when he does eat cookies, I also know that he makes a mess, right? And that's some reasoning. I'm not going to go into that reasoning about like what's going on about the mess, but I'm going to just say that I did not see the jar knocked over. That's my observation. So that is something that someone else could go in there and measure. They can confirm that the jar was not knocked over. Okay? So if we're going back to our rubric, our observations are in purple. And how this was measured was it was seen with my eyes. I am the source is what I would say for this as well. I think I'm going to include that for a couple of these actually, looking at it right now. So ideally, I could have like someone else also look, and then I could be like, I and my sister are the sources. So we could say maybe we both saw this, and now we've got stronger evidence because multiple people are confirming this, or multiple scientists, right? So we've got that. That looks pretty good. I'm just gonna honestly copy paste that to the other ones because that kind of is what's going on with our silly example. In our second source of evidence here that I'm providing, let's say that I checked my brother's hands and I saw chocolate on them with my eyes, and then I heard him say it was from a chocolate bar. I'm going to say that my sister and I are investigating this together. Or maybe this is, and my mother are the sources. So maybe my mother and I heard him say that. Maybe. It might be good to have different sources confirming this information. So here we've got in purple, we've got an observation that we saw, how it was seen as well. And then also I'm hearing him say that it was from a chocolate bar. I think that might be purple because that's something that I heard, right? So that's an observation that I'm making. This is probably my favorite piece of evidence because this is actually measurable. So this is a good example of what this might look like when we have a measurable thing. So here, I saw that there were 17 crumbs on the couch cushion. And so I've got like whatever the unit is in purple, the number of things, whatever that thing is the unit. And then we got 17 crumbs, so that was orange, right? So we got that orange for the unit, purple for the number. I think that, let's say me and the sister are the sources for that one as well. Or maybe my father. Yeah, a different source is probably good. So this one has, all of the components, and it even had something measurable, which is always nice. And I will tell you in the rubric if there's something measurable or not. Like this will tell you that this is observations or units. And if it's observations, there won't even be an orange thing on there. Okay? I think that might be what we have for our prompt for this week. Okay, so that's the silly example. The reasoning doesn't really apply here because there's no scientific terms here. So if you look at our reasoning rubric, it doesn't really work because I can't highlight anything and I can't measure how many general things they used correctly because there's no terms. If I'm looking at this reasoning here, though, if you read through it, you can kind of see how I'm explaining things. This is like my logic or my thought process. This isn't stuff that I can see, but these are thoughts that I have about what I've seen, or ideas that I have about what I've seen. Okay, so let's also look at a science example. This might be a little overwhelming for you. I'm just gonna tell you that's okay, but remember you can rewatch this. You can also use that transcript tool to go back and forth. I know this is a much longer video than what I normally do. Again, just do your best with the CER and we can go over it next week. And we will go over it next week. So for an actual science example, let's look at what this looks like. Hold on, this is, yeah. So I think I had written in a bad example, so this would get like no points, right? This I think actually should be getting 3 points. And this is kind of, I'm not sure if this is sufficient. I'm not sure how I would score that. There is sometimes things where I'm not sure where this is like either a 2 or a 3, where it's like this isn't really addressing the global rise in climate change explicitly. So I'm not very happy with that. Like if we look at the general rubric here, yeah, it doesn't like answer the question directly. It kind of partially answers it, in my opinion. So I would say that's like a 2. Like this statement right here is worth like 2 points if that was your answer. This would be worth 0. This would be worth 3. So I'm gonna get rid of those ones that I don't like. And we're gonna make that actually be right color. And I think I'm gonna actually go back and do that here as well. Yeah, that looks better. Okay, so now for this claim, if I'm talking about climate change, I'm not going to go into all of this evidence, but I'm going to talk about the general idea of like a quality response using data. So I know this looks like a whole lot, but I've basically written a couple different responses in here. And so basically I've tried to score them. So here, if you look at this evidence right here, this is starting to talk a little bit about reasoning, to be honest, with explaining what a greenhouse gas is. Like a greenhouse gas is a scientific concept, and we're kind of explaining what it does. You know, so that to me seems to me like that contains some reasoning. So I would give that like on the rubric. Or wait, no, was it evidence? No, it was evidence that had some reasoning, so that would be kind of weak evidence because we don't want to go into that reasoning right now. So let's scroll back down to that right here. Yeah, this had reasoning. Okay, I'm adding this after the fact because I realized I totally messed up. When I was talking earlier, I was talking about claims when this is totally evidence. So this right here is evidence. If we look at evidence on our rubric, so we're in evidence, our rubric, if we've got reasoning in there, it's containing reasoning, that's really bad evidence. This is something that I really do not want you guys doing. So this actually is a 1, which is weak. Because this is evidence right here. And we're going into that reasoning right here. This type of evidence, if you're giving me stuff like that, it's gonna be considered a weak argument. Here, there's been a rapid rise in global temperature. Okay, how do you know that? Like, if this was alone, what you had written in for this box, this is a pretty terrible piece of evidence. Sure, there's an observation there, but you can see that it doesn't tell you where they're getting the information from. It's not measurable. It's just an observation. They're not telling you how they measured this. This evidence is very, very not compelling to me. So if I look at this right here, the rapid rise in global temperature, just giving an observation alone is going to score pretty lowly on this. I would say it's good or weak. Yeah, I would add that evidence is missing many components. Like, it's missing a lot of those pieces. So this was pretty terrible. I would say that's a weak response. This one is stronger. They're giving a little bit more components. I would say that that's approaching the good kind of quality response because they're telling me, oh, this came from this source, and it's telling me what figure to look at, and it's telling me the observation that they made. So it's getting closer. Here we've got a measurable thing, like a degree change, and some time that's happened over. So some good quality measurements that we can confirm. And it's telling me where that's come from. This is approaching the strong, but I think this is still 2, and it's good because there's still some other aspects that we could be labeling. Like this one has actually no, this one doesn't even tell you where it came from. So this is also a 2 good because I did not include the dark blue in this. If you look here, the dark blue would be, what was it? How to collect the data, or how the data was collected. So I did not explain how the data was collected there, which I would probably want. So this is still just a 2 good. It's not like a 3, which is strong. This though, this is strong right here. This is really nice evidence right here. This is when you're writing a scientific argument, this is what you want as evidence. You want something that's telling you, hey, this is the source of the information, like it's in this figure from there. It's giving me measurements that I can confirm, and I can look back as well at some data to see that. It tells me who collected the data as well, and how they collected that data as well. So this is very strong. This though is pretty weak. I would again say that this is a 1, which is weak because there is a claim, it's just not very good. Or there's evidence, but it's just not very good. It's just observations. And then this right here, I would say is probably a 2, and it's good because it's giving me some components, but it's not a lot, right? So you can kind of see how I would go through actually scoring some evidence with actual data. And then this is what the reasoning might look like for an actual science response. So here I've got scientific terms, they've been labeled, and I'm using them appropriately. So for example, I'm talking about temperature correctly. So I'm indicating that I know that temperature is talking about Earth getting warmer and ice melting, and I'm demonstrating that I know these things are connected and how they're connected. I'm also explaining what a greenhouse gas is and then how it heats up the Earth. So I'm explaining what these things are and why they're causing the Earth to heat up. All in relation to this claim that we're causing this global change in temperature, global rise in temperature. So I know that's a whole lot, and I know if you're like any of my students that I've had before, you kind of feel like you're shutting down a little bit right now, and you're like, wow, CER seems impossible. And I know that feeling, and I've talked with adults who feel very similar. We've tried to give you a detailed rubric that will help you know, have I measured this correctly, or have I done this correctly, and how can I do better in like a measurable way so I can give you some feedback. That's my hope, at least. So I'm gonna wrap this all up, and we're gonna look at the final rubric that you have for the prompt for today. This is your final rubric. I think it's on slide 18 right now, and it should also be, I'll try and link it for you, maybe like either, I know Canvas, you can have the rubric straight on Canvas. I'll try to have it there, and I'll try and also maybe insert it before we go into this silly non-example. It might be like in between slide 7 and 8, but it should say beach erosion. Okay, this is the CER beach erosion CER rubric. There were not any measurements, so you just are doing observations. I'm expecting you to get 4 different pieces of evidence. There's 3 sources. So one of the sources, you're going to get multiple pieces of evidence. You might get 2 or 3 pieces of evidence from one source of information. So I would like you color coding those pieces as well to just practice identifying. Have you really got an observation in here? Like, what is the observation? And like, where is this information coming from, essentially, is kind of what we're doing. Um, there are 3 different sources. And so if you get evidence from 2 of the sources, you don't get one from a third. That instantly puts you in this category. So you do need to get evidence from at least 3 different sources to be in the strong. And then for reasoning, here are the terms that you should be using: weathering, erosion, water, deposition, and sediment. You should show some understanding of those words. I know I haven't focused a lot on this word. I mean, you can like use your resources, you guys. You can look up definitions for these things, but don't use a definition that you don't understand. And don't just give the definition. That's not going to count for this. You have to show how it relates to this term. So if you just give it like 4 defined terms, that's terrible reasoning. Okay, this needs to explain to me how the claim is linked to this evidence through that reasoning. Kind of like how in that silly example, I was saying like, hey, like I know what's going on with my dog here. I can explain why we're seeing the cookie jar is not knocked over. The dog didn't do anything. Okay, so that's tying together what I saw with some thoughts that explains why I think my claim is true. So yeah, I know that you may not be feeling super great about this, but this is growth mindset. I know that uh, I'm excited to see the responses that people get, and I'm excited to grade some of these and give you some feedback so that you can get better at this, because this is really how scientists operate, and it's good for us not to just do rote memorization, but to actually try and think about this in a deep way and get good feedback. It's like real school again. Yay. Okay. All right, well, if you've got any questions, we'll go over this in class on Monday, and I'll even have some supports for writing this for those of you who are like, I can't even start this. I'll have some stuff for you next week, but I want you to try doing this on Friday. Okay, just give it an attempt. All right, cool. Thank you for joining me. This has been Mr. McLaren.